Okay, just a reminder of what we were doing yesterday. What you were doing yesterday was the intersection of two lines is either one solution, no solution, or infinite solutions. If we're going to figure out whether these two that are here are solutions or not, we're going to go and graph this, but I want to do it by finding the y-intercept and the x-intercept. So to find the y-intercept, that happens where x equals 0. So if I put a 0 in for x, then I get a 3. And so y equals 3. The x-intercept happens where y equals 0. And that would happen, you solve this for x and x equals 3. So this is a graph of a line that looks like this. This one has a slope, the second line, of -1, the y-intercept of 0. So you plot those, and then you draw the line, and you can see there's a parallel, so these are no solution. For this next one, if we do the same thing, make x equals 0, this becomes 3 times 0 equals 11 minus y. So I get 0 equals 11 minus y. Add y to both sides. And y equals 11. So that would be the y-intercept. That's a way up here. Okay? And then if we do the x-intercept thing on this one and find the x-intercept, we end up with 3x equals 11 minus 0. So x equals 11 thirds. So this is turning out to be not a very pretty one. That's going to be 3 2/3. So this is going to be huge. It's going to go all the way down to here. If we graph the other one and figure this other one out, it becomes y, and solve this one for y, it becomes y equals 1/2 x minus 3. So we go up 1 over 2, up 1 over 2. Looks like I got my intersect right there. But you can see how messy these become. So we're going to learn some other methods that help us with this. So this has one solution right here. And I'm going to estimate that it's at 4, -1. If you want to check the exact value, you can do this on your calculator. So for these videos, remember you can pause anytime you need to practice or just review. You can also pause it before we get to the next slide. Go to the next slide yourself and see if you can do it. So here we go. Today we're learning to solve systems of equation by substitution. And then we're also going to do word problems. There are 3 steps. First thing is you're going to be given 2 equations. You solve one equation for one variable, like x equals, y equals. Step 2 is you substitute the resulting expression from step 1 into the other equation. And then you solve. And then the third thing is that you're going to plug in whatever you find into the other equation and then find the ordered pair. So here we go. We're going to use substitution to solve the systems of equations. You're looking for a y equals somewhere if possible, or some equation that you can make this an easy y equals. This one already has a y equals. So y is a -4x plus 12. So in the next equation, do you see where that y is? Y is -4x plus 12. So I'm going to take the second equation, and instead of this y, I'm going to put a -4x plus 12. And that equals 2. So this, all in this parentheses, was y, and I replaced it. You remember why? Because y equals -4x plus 12. So now this becomes 2x minus 4x plus 12 equals 2. -2x plus 12 equals 2. So this is just solving from here on out. Notice I combine my like terms right here. So I take away 12 from both sides. I get -2x equals -10. Divide by -2. Divide by -2. And x equals 5. But that's only half of the equation. We still need to find y, so you have to find both of the variables, because where the two lines cross is an intersection point, and that's going to have an x value and a y value with it. So now, step number 3 was you take this and you substitute it into one of your equations. It doesn't matter which one, but I will tell you that if there's already one solved for y equals, that's the one you put it into. So this is 4 times 5 plus 12. So y equals negative 20 plus 12. So y equals negative 8. So the coordinate point, or the solution to the system of equation, is 5, negative 8. And that would be the answer. You might want to try this one yourself first and see if you've got it, or listen to me again. So y equals 2x. So instead of y in the other equation, I'm going to replace that with 2x. So 3x plus 4 times 2x equals 11. 3x plus 8x equals 11. You get 11x equals 11. So x equals 1. We got half of it. Now how do we get the other half? We plug it into the y equals equation. So y equals 2x, but now we know what x is. So y equals 2 times 1. So y equals 2. So the solution to this is x. Let's try that again. Is x is 1, y is 2. As a coordinate point, it looks like that. Okay, this one is a little bit trickier because we don't have one set up with x equals or y equals, so you can change it to x equals. The easiest one to do that on is the one with the bare x or the bare y. So let's switch that around a little bit. So the first equation then, x minus 2y equals negative 3. We're going to take this x and keep it on one side because we want x or y all by itself. So this is x equals 2y minus 3. So now, instead of x in the second equation, 3 times 2y minus 3 plus 5y equals 24. So this is where distributive property matters. Remember, don't do anything until you've gotten rid of the parentheses by distributive property. Don't forget both of those. So this is now 6y minus 9 plus 5y equals 24. Combine your like terms and you end up with 11y minus 9 equals 24. Then we're going to add 9 to both sides. And 11y equals 33. So y then equals 3. So the coordinate point for this, we just found y, right? So now that I know what y is, I can plug it back into the x equals equation. X equals 2y minus 3. So x equals 2 times 3 minus 3. So x equals 3. So the coordinate point for this one is x equals 3, y equals 3. There it is. That's where the two lines cross. Remember, you can pause this or repeat it any time, okay? Alright, so here's another one, a little bit trickier. It's okay, you'll be just fine. Just go and figure out, see if there's a bare naked letter there. So here's the bare letter. Okay, so it has nothing with it. So this is now 3x minus y equals negative 12. I'm going to get that y all by itself. So I'll take away 3x. There is a faster way to do this, but I'm just going to follow the steps. So this is negative y equals negative 3x minus 12. Multiply every single term by a negative 1 so that we can get rid of that negative in front of the y. Now we've got this bare y. So the y equals 3x minus 2. So we're going to take this and we're going to plug it in to the other equation, the second equation that we didn't turn around. We're going to put it in for y. So instead of y, we're going to put 3x minus 12. So this equation becomes negative 4x plus 2 times 3x minus 12 equals 20. Notice that I put my substitution thing in parentheses. That helps save a whole lot of mess when you're messing with, when you're substituting these in, and you make sure and keep the 3x minus 12 together, because otherwise you might not set it up to do distributive property and then you'll get it all sorts of wrong. So we're going to do this. Negative 4x plus 6x minus 24 equals 20. So 2x minus 24 equals 20. Add 24. 2x equals 48. So divide by 2. So x equals 24. So now we just have x though. Remember, we got to go and figure out what y is by plugging in the x equals 24 into the other equation. So let's go ahead and do this one. Let's see where I am on my notes. Okay, I went back and checked my work just to make sure that it was right before I went any further. So I see that I missed something over here. So you should always check once in a while. So this is 3x plus 12, which makes this 6x plus 24, which makes this plus 24, which means that we're going to be subtracting 12 from both sides, 24 from both sides. So this changes things just a bit. So we end up with negative 4, so we end up with x equals negative 2. Okay, now we'll substitute that in now that I've checked my work. So y equals 3 times negative 2 plus 12. And while I'm on the topic of checking, I'll show you how to check your work to make sure you did it correctly. So y equals 6. So there's our two numbers. So now I'm going to check this. And the way that I check it is I use the original equation, 3x minus y equals negative 12. Plug in my x value that I found, which was negative 2. So 3 times negative 2 minus my y value that I found, which is 6, equals negative 12. And then you do the math on this to make sure that the left side equals the right side. So it worked in that one, but you have to check both of them. So negative 4 times negative 2 plus 2 times 6, because that was our y, and this is the second equation, equals 20. So if I do the math on this, I get 8 plus 12 equals 20. So I get 20 equals 20. So my coordinate point worked in both of them. So x equals negative 2 is the correct answer, and so is 6. The whole entire coordinate point is your answer. Sometimes you'll have no solution or infinite solutions. If I set up this one and work it, when I did this on my equation, I got negative 6, no, not that one. I got 0 is not equal to 8 when I worked it out. If you end up with the left side and the right side not the same, then this is a no solution, but you better go and check your work to make sure you did it right. Okay, and I'll show you that in class if you need me to. This one right here, solving the system of equations by substitution, you end up with a negative, or I did, with a negative 6 equals negative 6 when I did my substitution and solve. So when you get both the sides the same, then this is an infinite number of solutions. In fact, I bet if you solved each of these for y equals, which I don't want you to do, I want you to solve by substitution, you probably would see that they're exactly the same line. So this is the infinite number of solution, or you say all real numbers. Okay, this word problem, I'm going to continue this on part 2 video, and then there's another sheet. You should have a packet with the slides, and then there's another sheet that's all by itself. So I'm going to put this in with that video. So I'll see you in a bit.